Hello. In this session, I want to show you how to do correlations using Rapidminer. Last class session, we looked at the conceptual basis of correlations, and today we're going to see how to do it using Rapidminer. And correlations are essentially useful statistics for figuring out relationship between variables. Okay. And they are usually measured using correlation coefficients. Correlation coefficient is depicted using R or maybe the Greek alphabet rho to quantify the relationship between two variables. And of course, they have to be numeric variables. You cannot do correlations between a numeric and a non-numeric variable. Both have to be numeric. And the value of R, it ranges from -1 to +1. And -1, so it's dimensionless. It doesn't have any unit of measure. It's a pure number, and it can vary from anywhere from -1 to +1. Now, if it is -1, it means it's a strong negative relationship, and if it is +1, means close to +1 means strong positive relationship. Now, of course, as analysts, we are interested in both strong negative relationship as well as strong positive relationship. And negative relationship means as one variable value increases, the other variable value decreases. So it's a kind of a negative relationship. The positive relationship, that means if one variable value increases, the other variable value also increases. And so it's useful to find any number that is high, absolute value being high, and that'll be useful. Now, if the correlation coefficient, on the other hand, if it is close to 0, then that means it could be just there is no relationship between two variables that you calculate. And R is, of course, there is a rule of thumb depending on what field of study domain you are using. If R in social sciences, if R is, the absolute value of R is, 0.3 or higher, then that will be of interest. Okay, so that's a kind of a basic, again, background to correlation, just to refresh your mind about what it is. And today we're going to go on to chapter 4 of the Rapidminer book, or data mining book, and the data file itself can be found from the data mining for the masses website, and we're going to download chapter 4 for that. Alright, let me go ahead and click on this, and this should load up your browser and point to the Google sites that's got data. Okay, there it is. So now here we want to download this file. Okay, when you're downloading, it might download to your downloads folder. Later you may want to go to some place where you know where it is. I have already downloaded it, and it's in my computer. Let me see, that's 7, and so chapter 4. I saved it as chapter 4 heating, and it's a CSV file. So let's take a look at the contents. And CSV files by default get open using Excel. Excel knows how to convert the commas and put data into separate columns. And so we've got data on insulation, temperature, heating oil amount, number of occupants in the house, average age of members in the house, home size. Now these are, as can guess, information about data about some homes where we have occupants, and how much heating oil they use, and how old or how good the insulation is, and what is the temperature outside. Okay. And so based on the temperature outside, you want to know, the heating oil is, could be high or less. Obviously, if it is like, if it is very cold, then you're going to have use more heating oil, and versus if it is hot, you may not use as much heating oil. Okay, so, and also the heating oil usage depends on how good the insulation is. It also depends on how many people live in the house. It can depend on average age of the household members. It may also depend on size of the home. Alright. So we got all numeric. We got 6 columns of data, and if you want to do correlation between them, you need to choose. We can do correlation between any two of them. Okay. So you can do between insulation temperature, insulation and heating oil, insulation and number of occupants, and so on. So so possibly you can have 30 combinations of correlations, or and if you do correlation between insulation and temperature, that's the same as doing correlation between temperature and insulation. So you get the same results. Okay. So we have 5 plus 4. I believe there will be 15 possible combinations. Okay. So insulation and temperature will be 1, insulation and heating oil will be 2, 3, 4, 5. The temperature of the heating oil is 6. Temperature and number of occupants 7. Temperature and average age 8. Temperature and home size 9. Then heating oil number of occupants 10, 11, 12, 13, 14. Let it count 15. Okay. But we'll see. Okay. But the idea is once we have this data, we want to do correlation. If you want to do it in Excel, it's a little bit tedious because you need to use an Excel correlation function, and you can do only one correlation at a time. So if you use Excel correl function, we're going to specify 2 arrays. The first array would be A 2 to A 1299, 1219, comma, and the second array will be B2 to B 1219, and there it is. So strong negative relationship, and insulation and temperature. Well, I don't know why that should be, but I guess depending on your temperature, people have different stronger installations and so on. Alright, so this is between just one. Now if we have to do 15 other such correlations, it can be tedious. Rapidminer is very useful in doing multiple correlations very quickly. Right? So I'm not going to save this, and also notice we've got a huge number of records here, and if you can see, there are more than 1200 records in this data set. Alright, so this. So I'm going to fire up Rapidminer and import this data into here, and then do the correlations. Okay, and Rapidminer 5. And start with importing the data first. So file, import data, import CSV file, and I have downloaded it to my CS07 folder. Next, and so this will kind of getting, as soon as you select the file, it's going to take you to the wizard to help you import the data, and the data is all separated by the commas, so we'll choose comma separated, and so click next, and then we have the first it's all the first row is all names of the attributes. ATT stands for attribute. Click next, and so that it automatically figures out these are all integers and real numbers and so on. That is fine. So then click next, and it's ready to be saved. So let me save it as chapter 4 heating. And finish. So chapter 4 heating has been downloaded, and we got big number of 12, 18 records. We can do a metadata. Metadata will summarize the data for us, and each variable will tell you average is that much. That's a standard deviation, and range is insulation goes from 2 to 10. Temperature average is 16.65.79, and standard deviation of 16.932. That's a range. And so we got data, and also there are no missing values, so we don't have to worry about cleaning up the data. The data is already clean. And so let's go ahead and take a look at the data again. It's the data. We got 1, 2, 3, 4, 5, 6 columns of data, and these 6 columns we want to do correlation. So let's switch to the model view. And in model view, what we need is first we need to pull our data set into the design area. So drag our data set from here, from the repository area to here, and then simply connecting this will summarize the data here and show us the results. And we run it, and there it is. It's the same thing what we've seen before, but it can also be done using a simple model. Now what we want is not just the summary, but also we want to do correlations between those combinations of variables. So look for an operator called correlations, and it should be under modeling, and we want correlation matrix. So select correlation matrix and drag that, drop it there, and of course the data from this has to go to the input part of input port of the correlation matrix, and the output port of correlation matrix should go to the results. Okay, and also we have a matrix itself will be created. So what is the matrix here? Well, we have a correlation between two variables at a time, and there are 6 variables that we are looking at, and so there will be a 6 by 6 matrix will be created, and this 6 by 6 matrix will have correlation data and calculated for us, and we don't have to write any formula, nothing like that, so it automatically calculates. Now it's up to us to interpret the numbers. Alright, so now we are ready to run our model. So what does this model do? It retrieves the CSV file data that is already imported from chapter 4 heating, and then the output of that gets sent as an input to correlation matrix operator, and the correlation matrix operator will send out 2 things. One is a summary of the examples, summary of the records. Second is the matrix itself. That also goes to the results screen. Alright, let's ready to run this. Let's go ahead and click on that, and there you go. So 1,200 records, and 2 combination of two variables at a time. It ran formulas 15 times, I believe. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 times. And this is the correlation matrix. Now this matrix is a symmetric matrix. If you notice, the diagonal element is all 1, so that means correlation is 1. And you can tell why, because if you run a correlation between insulation and insulation, you would of course get insulation you would get 1 as the attribute, 1 as the, okay, I think I missed it up. Let me just go back and run this one. Very good. Okay, so these diagonal elements are all 1 because the 1 represents correlation between insulation and insulation, or correlation between temperature and temperature, and so the diagonal elements are basically correlation that's not of much interest. Okay, but the non-diagonal elements show us the correlation between the 2 variables that are different. So between temperature and insulation, there is a 0.794. If you remember from Excel, when we ran the correl function in Excel, we got the same result, 794. That's what we do here. And then between heating oil and insulation, there's a strong relationship. So I guess the insulation column refers to the number of years insulation has been in place, and I guess older the insulation, more heating you would need. So it's a positive relationship. Also, it's a pretty strong relationship, 0.736. It's a strong positive relationship. Average age of home also has a higher insulation age, so 0.643. Home size doesn't have much correlation with insulation. It's only 0.2. And we'll be looking at this correlation matrix. You could be looking at either the top half or the bottom half. It's the same thing. And between heating oil and temperature, as temperature drops, heating oil costs or consumption goes up. So obviously there is a negative relationship. As the temperature raises, you don't need heating oil as much. So that's a negative relationship in heating oil and temperature. Again, a fairly strong negative relationship. That's good. Number of occupants doesn't seem to have any effect on temperature. Okay, I'm sorry. Number of occupants doesn't have any correlation with temperature. That's more. Why should there be? There are people there whether the temperature is high or low. Average age of people interestingly has a negative relationship. I don't know what to make out of it, but it's interesting. Then go to the next column between heating oil number of occupants. There is no relationship between heating oil consumption and number of occupants. You might think more occupants means more heating oil, but doesn't seem to be that. If average age increases, heating oil seems to also increase. So it's a fairly strong relationship there between heating oil and average age. You could make an argument that maybe people who are elderly might want their homes more warm and may have cranked up the heating a little bit higher, so consuming more heating oil. And let's go to the next one. Home size doesn't have a whole lot, it's only 0.38. Still, it's kind of interesting, and so home size does seem to have somewhat a weak relationship with heating oil. And let's go to number of occupants. With average age, there is not any interest, no interest of number of occupants to home size. Average age to home size, again, there's not much interest there. Okay, it's 0.307. It's a little bit interesting, but since we're interested in the outcome is the heating oil consumption, and the average age and home size is kind of secondary to our research. So this way we are able to do correlation between these two variables and quickly summarize the data, and it's very useful to know. And as a data mining analyst, you would find interesting patterns, and these patterns can be used to suggest business policies, and it can be used in decision making and so on. And especially like high numbers like 0.736 or 0.848. These are high numbers. Those are very useful kind of considerations. And once we got this much data, we could also look at the same data using plots. And remember in the class of the day when we said before we do correlation coefficient, we also looked at scatter plots, and it'd be nice to see scatter plots between the data. Okay, and so you can do a scatter plot between. So I go to plot view and pick on the x-axis. Got to switch to this and then fix plot view. So I switch to example set tab and then choose plotter. So I'm plotting the actual values of the raw data, not the correlation. I'm not plotting correlation, but I'm plotting the data. So select scatter and then select x-axis, and for x-axis I want to maybe show insulation. On the y-axis I will pick heating oil, and in heating oil, as you can see, the heating oil data is on the y-axis, and for smaller values of x, we have small values. For smaller values of insulation, the heating oil consumption is low, and so we can see if insulation is relatively new, then you have less heating oil consumption. If the insulation is older, like in this case of 6 years or above, or 6.5 years or above, there is more heating oil consumption. There's a definite pattern there. Okay, and also sometimes it's useful. You can also switch to some other, let's say, temperature. Okay, lower the temperature, as you can see, higher the heating oil expenses, higher the temperature, very distinct two groups of data. And then let's go to number of occupants. Number of occupants, that doesn't seem kind of all over the place. We don't have a whole lot of data set with many um, large households, but there is no real variation between heating oil expense for the number of occupants. Average age, that is definitely a trend here. As average age increases, heating oil expense increases too. Okay, that's definitely kind of going up. And on the x-axis, home size, again there is not a whole lot of difference. I guess larger homes tend to have somewhat higher heating oil, but then the range is very similar to smaller size homes. Okay, all right. So we can look at two-dimensional scatter plots like this, and as you can tell, doing scatter plot like this is a lot more easier and fun than doing using Excel. Not only this, we can also add another column to this. So let's pick the first one, installation. So within installation, I can add a column color column, and I can, let's say, increase by number of occupants. Okay. So what I have is I added color-coded these dots based on number of occupants. So the number of occupants is 1, that shows in blue. If it is very high, up to 10, then it shows in red, and mid between is green. Okay. So these color codes can also be useful to know, and we can change something else, temperature, and so again, adding color code to the temperature gives you a third dimension to the data. So data mining using Rapidminer, as you can find, it's fairly interesting and fun to do, and these are things you could demonstrate to anybody who's interested in what you have found. And okay, now one other type of chart you can do is a scatter 3D, and scatter 3D, again using the same data, we can do a 3D scatter plot, and in this case we will pick scatter 3D. Good. Insulation would be x-axis. Y-axis I will pick for the z-axis, the height, I will pick heating oil. So y-axis temperature, heating oil, there you go. So now remember, on the x-axis I have installation, that's a number of years installation has been in place, and then the y-axis the temperature, outside temperature, and the z-axis the height, depends on the amount of heating oil consumed. So now this is you can move this around. It's very cool. You can move this around, and as you can see, we're just looking at different values of x and z only, and definitely for x is our installation, so, and that is so z is oil consumption increasing. Okay, and then we can also look at the data between y and z. Okay, so y, so the first one, this was y and z. That's what I did first, temperature and z. So as temperature, low temperature, we have higher consumption of heating oil, high temperature, lower consumption of heating oil. And if you flip it and take a look at the x-axis, that is insulation. So that is x. So x goes from 2 to 10. So on the left side here means older insulation, and the right side here means newer insulation. And so obviously with older insulation you're going to have more consumption. Okay, and so a 3D plot like this is really, I thought it was nice and cool. Alright, so I'm going to stop with this for the correlation, doing correlation using Rapidminer. Alright, thank you.